Now we will continue where we left off in the notes for point slope form. So here we have another example. Again, this problem is worked out for you, so you have an example to look at. It says here that a line passes through two sets of points. Now, they want to know what is the equation for this line in point slope form. So that's first. And then they want to know what's the equation if we write it in slope intercept form. So there's kind of like several parts to this problem. So again, we kind of go through this in steps. So the first step is we're going to use the two given points to find the slope. So we use our slope formula, change in y over change in x. So our slope would end up being 5. Then step 2 is to use this slope and one of the points given to find the equation in point slope form. So I'm going to use the formula for point slope form. They picked the first point. So they're going to substitute 1, 4 in for x1 and y1, and then you substitute 5 in for your m. So that's what they did here. So there is their equation in point slope form. Now the next part is kind of in the middle here, and now we want to simplify. Since they want us to write it in slope intercept form, that means we need to get y by itself. So y equals mx plus b. So that means I'm going to use the distributive property, and then we're going to add the 4 to the 5 here, and that is how we get y equals 5x minus 1. And that would be your equation in slope intercept form. So just be aware there's a few steps. We're using the slope formula, we're also using point slope form, and then we're basically kind of just simplifying it to get y by itself. So let's do one and practice that. So here we want to write an equation from 2 points. In this case, they actually give us the graph, which is nice. So they want us to use the point -2, -3 to write an equation for the line shown. So we're going to just kind of follow those steps from the previous example. We can find our slope in a couple of different ways here. We can use the 2 points given here and use our formula, change in y over change in x. Or we can look at the scale here. Looks like it's going by ones. So we could simply do our rise over our run in this case, since it's in graph form. So looks like we're going up 7 units and over 3 units. So our slope is going to be 7 over 3, rise over run. Now the second step then is to take our slope and this point, that's the point they want us to use, and write our equation in point slope form. So I'm going to say y minus y1, which in this case is -3. And that's going to equal my slope times the x minus the x1, which in this case is -2. And we can go ahead and simplify because we know these will change to plus. So y plus 3 is going to equal 7/3 x plus 2. Now, once we have that, that's part of the answer. We are writing it in point slope form, but we can also rewrite it in slope intercept form as well. So now I can use the distributive property. So let's do that. So we are left with 7/3 x plus 14/3. And then we just need to subtract the 3 here. to get y by itself. So our equation that is in slope-intercept form is going to be y equals 7/3 x plus 5/3. Or I guess you could say 1 2/3, but same idea. So if we notice here, we wrote our equation first in point-slope form, and then we solved it for y to get y by itself. So now it is in slope-intercept form. So that just kind of gives you an idea about how to do that in all the different ways there. Now let's go to problem 4. So here we're just using a table to write an equation. So the table shows the number of gallons of water in a tank after X hours. So this relationship is linear. So they want to know what is an equation in point-slope form and what does the slope represent. So again, we need to just find a slope in one of the points. So to get our slope from the table, we're going to just look for our pattern here. And you only need to use 2 points because they tell you the relationship is linear. So we're just going to find the change there. So I'm going to calculate that real quick. So that's a change of 1250, and this is a change, of course, of 1. So our slope is y over x, so it's just going to be 1250. We could say 1250 over 1, but we don't need to write the 1. Next, we need to pick one of these points. So I usually pick the lowest point to work with, so I'm going to use 2 and 3320. So my equation in point-slope form to model this data is going to be y minus y1, which is 3320. And that's going to equal my slope of 1250 times x minus x1, which is 2. So there's my equation in point-slope form. It also asks, what does the slope represent? Well, if we look here, the slope represents the water or the gallons in a tank after X hours. So as the hours increase, the gallons or the water in the tank increases. So we would just need to explain that's what our slope represents. It's showing the water increase over time. So here we have just a kind of a summary. The point-slope form of this equation of a non-vertical line is this formula. Remember that x1, y1 represents 1 point on the line. And what does m represent? Well, m represents the slope of the line. So just to review what we've been talking about here. The last part, can any equation in point-slope form also be written in slope-intercept form? So give an example. So basically, if we take this equation, if we plug in any point and a slope here, can we write that as an equation in point-slope form? Now, can we rewrite it? Well, we just did that in several examples. So do you think any equation in point-slope form can also be written in slope-intercept form? So we can do that because all we're doing is solving for y. So the answer would be yes there. Okay, so that's the end of the notes for today. It's a little bit of a longer lesson, but I wanted to make sure that you guys had all the important information with those examples. So now it's your turn, and Your assignment is already in your notes packet, so you can get started doing that. Thanks. Have a good day, guys.